Hello everyone. In this session, we will study about the reflection of sound. So, as light wave, sound also obeys the laws of reflection. So, if any sound reflecting surface is there, we can consider a normal over here. We know that the normal is a perpendicular. In your textbook, there is an activity to show that sound also obeys the laws of reflection. So in that activity, we have placing a pipe which can direct the sound of a stopwatch here, and this is placed at an angle of 30 degree where the sound reaches the reflecting surface. From the other side, we take another pipe and change the direction in such a way that it is moved away from the normal. In a particular direction, we will get the high intensity of the ticking sound of the clock. So, when we place the pipe like this, if we suppose that we are getting the tick with a maximum intensity of sound, we'll place this, and when we note the angle, if this is marked 30 degree, this also will be 30 degree. So what does it mean? The angle of incidence of sound, that is here, that is the angle between the incident sound and the normal, is exactly equal to the angle between the normal and the reflected sound. So in this case, we can understand that the law of reflection, that is the angle of incidence of sound, is equal to the angle of reflection of sound. You have to note that this surface on which the sound is reflecting must be a good reflector while you do this experiment, and you have to do it in a very specific manner such that you have to listen to this reflected sound by keeping the instruments in the room like fans off, so that we can hear the clear intensity of sound. Hope you understood it. Now we are going on to the reflection of sound, and we term it as echo. So what is echo? Echo is the reflection of sound, or the reflection of sound is called echo. So here we will discuss what is the minimum distance from the source and the reflecting surface to hear a distinct echo. So let us understand it. Suppose there is a reflecting surface over here and a person is standing here. He sends a sound just like a clap. He sends a sound such that the sound hits a reflecting surface and comes back to him. So this is the original sound and this is the echo we hear. But there is a condition for us to hear a distinct echo. We have to distinguish the echo with the original sound, right? So the first feature that to hear a distinct echo is that there should be a time lapse equal to 0.1 second, or there must be a time difference between the original sound and the echo, which is equal to 0.1 second to hear a distinct echo, or to distinguish the echo from the original sound. Because the sound in our brain persists for 0.1 second after the sound is heard. So, in order to hear the echo very clearly or distinctly from an original sound, the time lapse between the echo and the original sound must be at least 0.1 second. Keeping this time factor, we will now discuss what is the minimum distance needed between the source of sound and the reflecting surface to clearly hear an echo. So listen, suppose this is the source of sound and this is the reflecting surface. So we know that the sound travel like this. Let this distance be x. This is the distance that we have to find out in this particular case. That it is the minimum distance between the source and the reflecting surface to clearly hear an echo, and clearly we have to distinguish between the echo and the sound. Let the sound travels like this and get reflected back. Consider the speed of sound at 22 degrees Celsius. Suppose the surrounding medium is having a temperature of 22 degrees Celsius. So the speed is 344 meter per second. And what must be the time elapsed minimum required? It is 0.1 second. So sound has traveled from the source to the reflecting surface and back from the reflecting surface. So what is the total distance traveled by the sound? It will be 2x, right? So let us understand. How is speed defined? Speed is distance by time. So here the speed is given as 344 and the distance means the distance between the source and the reflecting surface is x. Again the sound has to come back. So the total distance traveled by the sound is 2x divided by t is 0.1 second. Here what is x? X is the minimum distance between the source and the reflecting surface. So we can write that this 2x is equal to 344 into 0.1 second. So 2x we will get it as 34.4, or x is equal to 34.4 by 2, which is equal to 17.2 meter. So while the conditions like 22 degrees Celsius where the speed is 344 meter per second, the minimum distance between the source and the reflecting surface, we mark this as x, right, must be 17.2. So in standard condition where the sound travels at a speed of 344 meter per second, the minimum distance required between the source and the reflector to hear an echo very distinctly is 17.2 meter. Because I have already discussed, the time lapse must be there of 0.1 second for our brain to distinguish between the echo and the original sound. Hope you understood it. Thank you.